Let's discuss question 6.55. Here the question is asking us how much mechanical energy is lost to friction if a 55 kilogram skier slides down a ski slope at a constant speed of 14.4 meter per second. The slope is 123.5 meter long and makes an angle of 14.7 degree with respect to the horizontal. We need to find what mechanical energy is lost to friction. So let us first write down what is given to us. Question has given me the mass of the skier, which is 55 kilogram. I have the initial and final velocity, which is the same since they have a constant speed. Constant speed means the speed will not change. So my V final will be equal to V initial, which is 14.4 meter per second. The length of the slope is 123.5 meter. And the angle theta is 14.7. I need to find the mechanical energy lost to friction. To solve a problem like this, we will use the generalized work energy theorem, which says that work done by the friction is equal to change in kinetic plus change in potential energy. And the mechanical energy that is lost is equal to the work done by the friction. So if I can find the individual values, change in kinetic plus change in potential energy, I can find out how much total energy, total mechanical energy is lost to friction. So let's start with change in kinetic energy. Let me call this equation 1. And we write delta K as the final kinetic energy minus the initial. My initial point is the start of the motion on the top of the ski slope. I will call this initial. And my final is at the bottom. The question here mentions that the speed is constant. That means both my initial and final speed are same. And if initial and final speed are same, initial kinetic energy will be equal to final kinetic energy. And if these two kinetic energy values are equal, the difference in these two values will come out to be 0. So change in kinetic energy will be equal to 0. Next, we find the change in potential energy. Change in potential energy, again, we write the same thing. Final potential energy minus initial potential energy. Now, final potential energy, since the skier comes to the ground at final position, here my H is 0. And if H is 0, potential energy at this point will also be 0. Because the only potential energy here is the gravitational potential energy, which is mgh. And if you are not raised on a height above the ground, this potential energy will be 0. So my final potential energy is 0, and my initial potential energy will be mgh. Change in potential energy will be negative mgh. Now I can substitute these two values of change in kinetic and change in potential energy in my original equation, equation 1. So we write work done by the force of friction equals delta K plus delta U. Delta K is 0, delta U is minus mgh. Now work done by the force of friction is also taken negative because work is defined as force times displacement. And this force of friction is always opposite to the displacement. If your object is moving to the right, the force of friction will go to the left. So my work done by the force of friction is also taken to be negative. So I will put a negative sign here for the work done. Then we rewrite this. I can cancel off the two negative signs. And I get my work done as mgh. Now what is my h? I have the value of mass. We know the acceleration due to gravity. What is h? H is the side which is opposite to my angle theta. So we will find h by using trigonometric ratios. And since h is opposite to theta, the trigonometric ratio that I'm going to use is sine theta. We know that sine theta is opposite side over the hypotenuse. So I can write my sine theta as h over the hypotenuse, which is L. And my h will become L sine theta. Let's substitute this in our equation here. I can write my WF as mgl sine theta. Now we have everything given to us in the question to solve this. M is 55. G is 9.81. Length of the slope is 123.5. And the angle theta is 14.7. When you solve this, you will find that the energy lost due to friction is 16909 Joule.